Welcome to Study Loop.
Hello everyone, today we're doing chapter 29, problem 10, and this problem is asking us to write or draw out the stepwise sequence that shows how a racemic mixture, such as leucine enantiomers, can be resolved into optically active amino acids using R-alpha-methylbenzamine. So let's draw our two enantiomers of leucine. So something to remember when we talk about resolving versus separating. So resolving means that we want to separate enantiomers. So therefore we gain resolution. So we have 1, 2, 3 carbons and 1, 2, 3, and off the second carbon we have another one. So this is the S enantiomer. And then over here we'll write or draw out 1, 2, 3, and this is now R enantiomer. So we have two leucine enantiomers, and what we need to do is now we need to convert each of these free amines into N-acetyl amino acids. So what we need to do is acylate both these groups. So we need to acylate them with this acetyl anhydride, and at which point both of these are going to get an acetyl. I don't know if you guys can see that. Both of these guys are going to get an acetyl cap off the nitrogen. So now, once we do that, we can do we can add the reagent in this is called the resolving agent, the R-alpha-methylbenzolamine, and that looks something like this. So the purpose of what we're trying to do here is enantiomers, they do not differ in physical properties. However, diastereomers do differ in physical properties. So enantiomers, if we just left this how it is, we would not be able to separate this based on boiling point, melting point, freezing point, any of that, because the enantiomers would not differ. They would both come out at the same time. So how would we separate the R and S enantiomer? Well, first we need to protect the amine, because the amine is nucleophilic. It can be reactive. So we'll protect that with a protecting group, just an acetyl cap, at which point we'll add the resolving agent. So once we add this R resolving agent, what's going to happen is that we're going to have some sort of proton transfer occurring with this resolving agent, which is in its R stereochemistry. And the proton transfer specifically is going to be off the ionizable groups, being these carboxylic acid groups. So what's going to end up happening is that the S enantiomer is going to be resolved to give us COO minus, and the R of the resolving agent is going to carry through. So we have now SR, which are diastereomers, and then we'll have the R also coming through, and then the original R from this resolving agent also going to come through. So all of these act as diastereomers to one another. So because they have the same configuration around all but one stereocenter, these are what we call diastereomers. So now you can separate these based on physical properties. And once you separate these, well, you can take now each of the separate solutions. So if you separate these, then the R will come out at a different temperature, or will melt at a different temperature, or evaporate at a different temperature than the S enantiomer. So we would have two separate solutions being separated through either distillation through boiling points or through densities or some other physical property. We'll be able to separate this and deprotect these acetyl groups by adding some sort of strong base. So very simply, you can regenerate the amino acid with the hydrolysis of this amide that we formed using some basic conditions such as just basic water, just water and hydroxide ions. And we would reform now the original amino acids. But now the interesting thing that is happening is now we're separated the two enantiomers. We have the S enantiomer in one flask, and then we get the R enantiomer in a separate flask. And here we have the R enantiomer separated from the S enantiomer. And as well, we regenerate our original resolving agent that we added to the mixture.